uh, say a few words about Professor Rinti Banerjee, in whose memory we have this lecture. I begin with a quote from Professor Banerjee, where she says, "Believe in yourself, follow the passion, it will happen in due course. Do not let others' perception affect you. Self-motivation, skills, and continuous commitment to one's passion and goals are very important." So you can see the passion that she had in her own life. And unfortunately, we lost her on 8 July 2021 due to post-COVID complications. Prior to that, she was a professor in the Department of Biosciences and Bioengineering at the Indian Institute of Technology, Bombay. She did her MBBS from the BJ Medical College, Pune, and PhD in Biomedical Engineering at IIT Bombay. She was then a postdoctoral fellow at the University of California, San Francisco, USA, and then returned to IIT Bombay for a faculty position. She was well recognized in the field of bioengineering, having done significant amount of work and made a huge impact in the area of biomaterials, bio-nanotechnology, and related fields. She was an associate editor with ACS Biomaterial Science and Engineering, as well as an advising editor to ACS Omega. She was an editorial board of many international journals. She also served as head of the Department of Biosciences and Bioengineering at IIT Bombay from 2016 to 2019. She was recognized also in India at various levels. She was a fellow of the National Academy of Sciences, Indian Academy of Science, and Biomaterials and Artificial Organ Society. And other than that, of course, she's received many accolades, honors, and fellowship, even during her short career as a researcher in this field. Her translational work in biomaterials, drug delivery, nanomedicine, and point-of-care diagnostics created a significant impact. She published more than 150 papers. She had either filed or had been granted more than 40 patents. She had an H-index of 50 and nearly 10,000 citations. Remarkably, she commercialized 26 technologies to various companies in India. And I certainly recall her even being active in translating technologies related to COVID before she herself became a victim of this of COVID. With that short summary, we recall and we mourn the passing away of Professor Rinti Banerjee. We would like to honor her with this endowment lecture, and for today's lecture we have Professor Uma Maheshwari. Professor Navkant Bhatt will preside over the lecture. Professor Navkant Bhatt is a professor at the Center for Nanoscience and Engineering and the Dean of the Interdisciplinary Division, of which bioengineering is a part. With that, I would request Professor Bhatt to take over the proceeding.
Thank you, Kaushik. A very good afternoon to all of you. And again, at the outset, I would like to thank Dr. Prasad and other members of Professor Rinti Banerjee for setting up this memorial lecture series. We really appreciate that gesture. I think it's very apt that the inaugural lecture is given by Dr. Uma Maheshwari Krishnaswamy, who is a pulmonologist. You just heard from Kaushik that Professor Rinti Banerjee succumbed to COVID complications. Professor Uma Maheshwari is a pulmonologist, pulmonary medicine, professor in pulmonary medicine at the St. John's National Academy of Health Sciences in Bengaluru. After completing her MBBS from Bangalore Medical College, she pursued her post-graduation in internal medicine and postdoctoral fellowship in pulmonology and critical care medicine from PGI Chandigarh. She has also completed a fellowship in sleep disorders conferred by Royal College of Physicians, UK. Dr. Krishnaswamy has been actively involved in research for 25 years and has about 70 publications in pulmonary and sleep medicine and holds a copyright for the Indian sleepiness scale. In her journey as a medical teacher, researcher, she has published original research papers in sleep medicine, interstitial lung diseases, COPD, as well as research related to instrumentation and monitoring devices in pulmonary and sleep medicine. She has collaborated with researchers from NHS UK, Indian Institute of Science, Postgraduate Institute of Medical Education and Research, Georgia Institute of Global Health, and MS Ramaya Institute of Technology for many of her research projects. In addition to conducting research, she has been a part of the scientific research committee and has mentored undergraduates, postgraduates, doctoral and postdoctoral students in medicine and engineering in their research projects. She is also a site mentor in the International Sleep Research Screening Program, which is, I think, belonging to World Sleep Society, and in the MECOR program of American Thoracic Society. She is the program director for a fellowship in sleep medicine offered by the Rajiv Gandhi University of Health Sciences. Her current areas of research include phenotyping, development of self-monitoring tools, and clinical decision support systems development in chronic non-communicable respiratory diseases, which is sleep-related breathing disorders and airway diseases. In addition, also on data mining from polysomnographic signals and novel device validation in respiratory and sleep disorders. Over to you, Dr. Maheshwari.
Thank you, Dr. Bhatt. And thanks to the Department of Bioengineering, as well as Professor Prasad, for inviting me to do this honor of delivering the first Professor Rinti Banerjee Memorial Endowment Lecture. I will start with this quote. I think you would have read this by now. This befits Professor Rinti Banerjee's description of what she did during her lifetime. So when I was reading about Professor Banerjee, what I realized is that we come across a lot of people at our workplace. We come across people as mentors, and we read about certain people whom we wish we had met during their lifetime and who had made an impact on our lives. Professor Banerjee is one of them. She was one of those people who dared to cross the realm of medicine into engineering, into foray into research, into biomaterials, and left a mark even during COVID before she succumbed to the illness. She did work on devices related to the biomaterials during her lifetime, and also during COVID developed masks with antiviral protection, as well as some nutraceuticals which could be used during COVID before she herself succumbed to the illness. So a big salute to her before I undertake this lecture, and a plea to all the students here to carry forward her dream. So let me discuss what I went through when I stepped into the realm of research as a clinician, the challenges I faced, the joys I had, and what I have unaccomplished, which I hope to accomplish in the future. So when I went through this process of preparing for this lecture, my thought process went through the following things. At first, I started recollecting. Most of the time, we are caught up in our day-to-day lives that we do not press the pause button and try to think about what we are going through or have gone through. When you try to recollect where you are in life today, all that we get is a box of mixed up puzzle pieces. But as we start pressing the pause button, we start introspecting. The pieces of puzzle slowly start falling into place, and then we reflect, and this results in clarity, learning, and growth. So not only did I prepare for the lecture, but a lot of introspection and growth has happened, and thanks to the organizers for enabling this. So where did I begin my career? I aspired for a career in medicine, driven by a desire to care and heal, and this started when I was a school student. I graduated from the prestigious Bangalore Medical College, which is called the BMCRI right now. We had a humongous caseload, but not much research exposure because we were busy curing patients. But the caseload sparked an interest in research. I went on to pursue my post-graduation and postdoctoral in PGIMER, Chandigarh, which is probably one of the best medical institutions to train in this country. And this led to a lot of changes in my persona and my perceptions towards research. So these, I have to credit all my teachers to making me what I am today. So I had mentors in internal medicine, Professor Jain, Professor Deeman, who sowed the seeds of interest in me, who would actively pursue me during my arduous clinical hours and ask me to pursue research. These were my doctoral thesis mentors who taught me the seeds of research. It was a life-changing experience at PGIMER. There was intense exposure both to clinical medicine and research. As I was pursuing my postdoctoral career, I had these excellent mentors, Professor Jindal, Dr. Behra, and Dr. Dheeraj, who are excellent role models and mentors. In PGI, whoever is trained here would know that there is a gentle, persistent nudge to undertake research and publish, despite our clinical load. And this honed my curious mindset. So I was out into the world after training, ready to practice and do research. And I joined as a medical school teacher. But a lot of surprise lay in store for me because coming from a tertiary care, one of the best institutions to India, to a medical school where undergraduates and postgraduates are trained, does pose a lot of challenge. The clinical load is humongous. You don't have time to even think about research. You are vested with a lot of teaching responsibilities, ranging from undergraduates to postgraduates to nursing students to other paramedical specialities. So that takes up a lot of your time. There are periodic knocks from the regulatory bodies telling you what to do and where to conform. And as a result, research and publications sadly take a backseat. And this left me in a very restless state with a fish out of water feeling because what I had learned in my alma mater could not be completely implemented in my new workplace. But the mind always adapts and tries to make changes. There were certain remedial measures which I attempted to put in place. I did them subconsciously, but when I reflect, I knew that something was in place. I tried to recreate the work system, the ecosystem in my workplace, which I used to experience at PGI, by assembling a whole lot of mentees, teaching them the ropes of research, trying to teach them clinical medicine across disciplines. I tried to learn medical education technology because in a tertiary care center, you're taught patient care and postgraduate teaching, but not much of undergraduate teaching. But I tried to learn medical education technology, and that was an exciting phase. And I started scoping for research partners and domains because that fire was still there in my belly. So, what was the salve to this restless feeling? IASC, the friendly neighborhood, just across the road. And my relationship with IASC goes far back to my high school days when I used to visit the campus with a friend. That friend is here in the audience. Her father used to be a professor in the IIC, and we used to just come into campus for its verdant green trees and the lotus pond and the good vadas we would get in the canteen here. And we would ask the professor some doubts when we had issues. Another batchmate of mine also had her father being one of the leading professors in IAC. So I used to come there, and it was a familiar place to seek out research partners. And of course, I had the good fortune of continued mentorship from my alma mater. Some of the research which I had taken up there was left undone, and they continued to handhold me until I could fly on their own, which is not a fortune which many of us have. We leave the shores and then we are forgotten, but my alma mater continued the handholding for some time. And this resulted in some of the first few publications. The first publication in interstitial lung disease, probably the first of its kind from the country, was from PGI. Also, this publication on fulminant hepatitis still continues to be one of a highly cited publication. This was also thanks to my alma mater, and this was one of the early publications from the Indian Institute of Science with the Department of Microbiology. And we have come full circle with me trying to collaborate with bioengineering again nearly 20 years later. After this initial boost, I tried to fly on my own, much like Jonathan Livingston Seagull, where I told myself, I don't mind being bones and feathers. I just want to know what I can do in the air and what I can't. I just want to know, that's all. So I went on to become mentor for MD thesis and student projects. tried some independent publishing, of course, had a lot of growing pains. A lot of youngsters here have the luxury of submitting their projects online, getting their rejections and acceptance online, and nothing to do with paper at all. But way back in our times, it involved 10 reprints being sent by registered post, getting the rejection back 6 weeks later by registered post, type everything and send it back again. So the wait was really painful. And when you didn't really have a peer group to bounce your ideas on, it was even more painful, doing all the corrections and waiting for another 6 to 8 weeks for that post to arrive. Around this time, I developed an interest in sleep medicine and medical device related projects, and I started pursuing them. But I did face a few challenges. Finding a research domain was one of them. Initially, I was unfettered and unhindered and started looking for peer group and mentors to pursue research. Funding and institutional support way back was still an issue 20 years ago. There were time constraints, like I told you, the huge burden of clinical work and teaching work. There was really no time for research. And then any clinician would be forced to look at the bottom of the evidence pyramid where you start looking for interesting cases. At least let me do something in the world of research. Let me look for case series and case reports, and that's where I began. That's where most clinicians begin. They start by publishing ideas, opinions, editorials. You read a paper, publish your opinion on that, publish some case series and case reports. That's where I began. And then the slow percolation of ideas happens and you start thinking of new research ideas. I kept trudging on and then stumbled upon a few initial research ideas, found this pain point of burgeoning sleep disorders. We spend a third of our lives asleep, and nobody is bothered about what happens when we are sleeping. Neither are others bothered until we snore.
We are not able to hear you.
So I hope I'm audible now. I can hear the echo, so I think I'm audible. So the second wind was when uh, there seems to be another glitch. Let me just set it right. Yeah. It was when I moved to the UK, and around this time, not only did I learn sleep medicine, but I also learned PowerPoint has kind of glitched, but I may be able to go on without it. Yeah. So I was also able to dive into sleep technology because my spouse was pursuing a PhD in sleep technology. So this was a period of intense learning for both of us, with him learning the technical aspects of sleep medicine, me learning the medical aspects. A lot of knowledge transfer happened. He completed his PhD and I completed my fellowship in sleep disorders. So a lot of mutual learning happened. And I did publish my first research paper in sleep medicine, thanks to Dr. Williams. And this was about looking at a biosignal. And this is when I started looking at biosignals, looking at pulse rate variability on overnight oximetry as a marker of a disease called restless leg syndrome. So put very simply, many of you sitting here in the audience, if you sit still for a long time, you may get a creepy crawly sensation in your legs. That is restless leg syndrome. And sometimes the same sensation troubles you at night. That's when it's called a periodic limb movement disorder. And we started picking that up from the pulse signal. And that's what my research was about in very layperson's terms. I was very happy that I was able to publish. But again, you have to come back and continue the research. I came back, rejoined a medical college, and now redoubled my efforts for research, which with newly armed research domain knowledge. I became a member of the Student Research Society, started mentoring students for what is called the ICMR STS projects. These are called short-term studentships, where you mentor medical college students or MBBS students. And believe me, that was mentoring MBBS students is one of the most fruitful experience because you catch them young before they have learned the wrong tricks. You mold them and you teach them the right ropes of research. And I had a very fruitful time with all my MBBS students. Some were STS scholars, some were not, some came out of interest. Many of them wanted to go to the US for a residency, so they came to me. But whatever be their motivation, I had a fun time mentoring them. I also was part of the medical school engineering college research committee. Some of my collaborators are here in the audience. We had a nice time getting engineering college students into the medical college to immerse and identify clinical needs and work on projects related to that. I also restarted my collaborations with the Indian Institute of Science and worked on a few sensor related projects as a clinical collaborator, and started, of course, continued my research in sleep disorders now that I could set up sleep services and could have a patient population on whom I could conduct research. The initial engineering collaborations resulted in a lot of research inputs. This involved mentoring final year engineering students. We worked on software for clinic workflow. We worked on incentive-based spirometry for children, biosignal processing, and of course, masters and doctoral projects in biosignal. Basically, biosignal is any ECG, EEG, or other signals used in sleep monitoring. We were able to look at that and derive surrogate parameters, and the initial few publications were like this. As you can see here, ECG-derived respiration, something to pick up sleep onset, and many of these are about sleep onset and EEG. So these were the initial few publications which we got on signal processing. Sleep medicine research also started picking up. We looked at sleepiness scale in patients with cancer. We looked at sleep disorders in patients with systemic disorders. We looked at shift work. I told you about shift work in sleep. We looked at shift work. This was a very good project. We got all the regulatory approvals and we were able to prove that sleeping at the wheel can cause near miss accidents. We looked at patients with stroke and sleep disorders. And of course, another project on cancer and sleep. But I was happy. Were the regulatory bodies happy? We were asked a lot of questions about why a pulmonologist was publishing in sleep and engineering. Was it enough to earn me a promotion? I had to answer a lot of questions about why I was doing interdisciplinary research. This is a candid recollection of what I went through, and I had to publish other articles to earn my recognition or career progression because none of these was considered as being good enough to become a professor in pulmonary medicine. So, side by side, I had to publish other things other than my own area of interest. So, these are some of the challenges which we face as clinicians. The regulatory body probably does not recognize the importance of interdisciplinary research. Hopefully, it will change in the future. So once this happened, what happens? You of course publish, you fire on all cylinders, you do clinical work, you get tempo from your publications of interest, and you publish another few to keep the regulatory body happy. But you start getting that weird pins and needles feeling. What am I doing here? Am I in the wrong place? Should I change course again? Is it really what I'm supposed to do? So I started looking for an ecosystem to balance clinical and research work where I would be respected for what I was and I would not raise any eyebrows in the regulatory body. So again, I took off, and the landing point was St. John's Medical College, where again, now I have a spate of research publications. We have the advantage of a research institute on campus. We have a health innovation foundation where we can incubate and patent our ideas and probably even have startups. I have a good peer group. A lot of upskilling in research methodology happened once I joined here, and I have a big spurt in research and publications right now. I continued collaboration with IISc, though I moved a city away literally in Bangalore's traffic terms. The magnetic fields grew stronger, defying the laws of physics. I have undertaken multiple projects from collaborator to co-mentor. I have ongoing projects with the Spire Lab since 2013 in airway diseases. Interinstitutional grant applications have been written, and I have been ideating about new projects with bioengineering awaiting kickoff. So I'm in a kind of comfortable position despite the burgeoning clinical load. I'm happy in where I am in my research position. So some of the publications which came here, these were the early publications from IAC where we looked at sensors to monitor human respiration. This was again with Professor Ashokan's lab where we published an article on fiber grating spirometer. This was validated in our PFT lab in St. John's. And the remaining publications are with the Spire lab with Professor Prasanta Ghosh. And this work is still continuing. We are expanding to move on from asthma to COPD to sleep disorders in this field on acoustics and voice recordings. I was also able to take disease-specific research without raising any eyebrows or causing any flutter. Now, here you will realize that once you get the freedom to do what you want to do, you are able to progress deep into your domain. So we started from epidemiology of sleep disorders. We went down to screening of sleep disorders. You can see that we went from prevalence statistics to evaluating a scale. We went to diagnostics where we evaluated available diagnostic modalities. We looked at consequences of the disorder. We also looked at therapeutic devices. And finally, now we are identifying phenotypes. We are looking at precision medicine in the same disorder. So look at what deep diving can do. I'm not a bench researcher who will look at a particular aspect of a particular disorder, but I'm able to deep dive into one disorder and take care of it in holistically. And we are also looking at biosignals, cytokines, markers of autonomic imbalance in patients with sleep apnea currently with NIMHANS. I've also had collaborative publications with my alma mater and with other institutions like CMC and with institutions outside of India. These are again different flavors, but again, it has enabled a lot of other publications. So where am I now? I have a team with complementary skills and common research interests. I've identified definitive disease domains for research. I have ongoing collaborations with many institutions. I am an advisor or have a reviewer role in many ICMR projects. I'm a mentor, as Dr. Bhatt already mentioned, in many mentorship roles. However, our efforts are intensely ongoing at procuring grants in the less recognized area of sleep disorders. The regulatory bodies or the people responsible for awarding grants still don't recognize sleep disorders as a focus area. So we are still working without grants, but we have a lot of data and we could make do until somebody wakes up to the importance of sleep. So how did the research areas evolve? We started with a broad disease area, chronic respiratory disease, narrowed down to sleep disordered breathing, COPD, and probably asthma, and then go on. This is how a clinician research evolves into subdomains of medical aspects like prevalence, clinical profile, and comorbidities. What is the translatory aspect, you would ask? I will come to it in a moment. We then go on to technical aspects like device development, workflow, and biosignal analysis. We go into biochemical and molecular markers like cytokines and transcriptomics. Now, each of these can translate. The medical domain can result in development of database and cohorts. The technical domain can lead to screening tools, diagnostic algorithms, and clinical decision support systems. And looking at biochemical and molecular markers can result in emergence of clusters, endotypes, and treatable traits. I may not achieve this within my lifetime, but I will create a stream of researchers who will carry it forward. Once there is a roadmap, somebody is going to carry it forward. It's going to take decades to do this, building cohorts, getting that much data. But the moment I have established a pipeline and a roadmap, somebody is there to carry it forward. So on introspection of this journey, I realized that a physician has many alter egos or avatars: the clinician, the teacher, the learner, and the researcher. The clinician's role is much like a roller coaster. It is vested with a lot of responsibilities, but one cannot shy away from it. It requires maximum time commitment. The clinician patient relationship is one like until death do us part. Healing goes beyond care. There is extended caregiving, end of life decisions, and patient family reaching out to you beyond the patient to handhold. So it is an emotional investment which every clinician has to make and cannot shy away from. And believe me, it is not mere altruism, it's a two-way relationship. It gives you the high and low, but it keeps you emotionally stable and grounded. It gives meaning to your research because at the end of the day, you want to benefit your patient. The teacher or mentor role is more like a placid river. It is a mandated yet very satisfying role. Time commitment, no doubt, is necessary. You do mentoring at multiple levels, but it is extremely satisfying. The researcher is like that distant tree atop the hill, very difficult for many clinicians to attain, mainly because of the current research requirements for progression and cadre, which are pretty stifling. Self-driven research is difficult to undertake, but possible. There is a huge clinical and teaching burden, which I've been repeating again and again, which relegate research to a low rank, but it is not impossible. We can do research despite all this. And the learner, it's important to keep upskilling and staying abreast of clinical important developments in your field. Otherwise, you get redundant and your patient will find another doctor. It's important to attend scientific meetings, to learn new techniques, to undergo training and research. And this, I believe, is a very satisfying part as well, because from being a caregiver, from being a mentor, you're being a recipient, and being a recipient makes you a child, and that's a happy part of life many of us want to be in. The complete persona of a clinician then is mostly a clinician, then a teacher, some part a researcher with some learner squeezed in between. But this is what makes a complete persona of a clinician. What did I learn from my research journey? This is the last part of my talk. What are challenges for clinician-driven research in our country? We have to essay multiple roles due to paucity of medical school teachers. Research training opportunities and options are quite limited. In an institution like mine, we have multiple online and offline modules. We have mandated modules. Everybody around me is undertaking some kind of research. So I am in an environment where I'm forced to do research or at least follow what others are doing around me. But that's not the case in many medical colleges where infrastructure is poor, there's a high case burden. Research is mandatory, but there's no time. I hear of many postgraduates who have lots of interest in research, but do not have time to do research. There are a lot of modules available online on NPTEL, on SWAYAM, but which postgraduate has the time to take these modules It's mandatory to clear. They would clear the module, but would they have understanding? That's a question. There is no concept of an ND PhD in our country, whereas in the West, an MD student can take a career break, do research, and return back to ND. But we are running on the hamster wheel. We want to finish our career fast and get into practice. So there's no pause button for research. And research is something which cannot be undertaken in a hurry. It needs time. There are regulatory body norms about authorship and publishing. The moment you enter the teaching cadre, you are expected to have original research publication within 2 years. It is really not possible. Research takes time. You cannot conceptualize, execute, and publish a research project in 2 years unless it's a shoddily done one. Again, about authorship. To become a professor, you need 4 publications as first author. Believe me, which professor would want first authorship once he or she becomes a professor? If you're last in the line, you're not considered a senior author. So there are a lot of issues the regulatory body needs to address. I won't take it up here and waste your time. There is lack of protected research time. People always find the time is what people tell me, but then it would be very nice if we had protected research time so that we could ideate, but we do find workarounds, which I will tell you. Again, another thing about clinician-driven versus bench research, because we don't have dedicated research time. Clinician-driven research largely proceeds from need identification to solution. We find problems in patients, we conceptualize a research project and find a solution. We have a wealth of clinical data available, which I can audit or data mine and find research problems, or I can even find questions or solutions. Research ideas originate during patient care, and quick solutions may be necessary. I can't wait for 5 years to find a solution. I think COVID drove home the point where there was a burst in research publications. Just about anything anybody did was getting published in open source journals simply because it was a desperate situation. We need scientific data to come out. Whereas bench research may be exploratory, it proceeds from idea to solution. It is time and resource intensive, and scientific rigor is necessary. Think of a scenario where there is collaboration between a clinician and a bench researcher. This is necessary for scientific progress. And we need to see more and more of this happening if we have to progress. What are the perks of interdisciplinary research? I've been fortunate to have collaboration across campuses. Exchange of ideas happens. I spent the whole day today visiting multiple labs, talking to so many people, and I feel enriched. I must have spoken continuously from 10 in the morning to 4 in the evening, and I still don't feel tired because I'm emotionally charged. So, fruitful translation of research can happen. You teach some, you learn some. I learned a lot. Like-minded collaborators, once you find them, there is no barrier of distance and time. I use my trips to the IISc to discuss with my collaborator as a getaway from my busy clinical schedule to ideate and progress in my research projects. And free research time is added. Somebody is doing the work for you and you can publish together. So this is one getaway I have figured out for my lack of protected research time. So I have a collaborator, I work with them, they work on the idea when I'm busy and vice versa, and we get out a publication. And here I would like to quote the African proverb, alone we go fast, together we go far. So interdisciplinary research is important. Need for dialogue and clinical immersion, especially if we are thinking of interdisciplinary research. Dialogue strengthens the research idea, and clinical immersion enables effective translation. Finally, what good is research for if you're not able to translate, if it doesn't see the light of the day? One case in point is a project which we executed in the engineering college, where engineering students wanted a solution for children performing a lung function test. Children cannot understand how to blow forcefully into a tube. So they came up, after observing kids performing, they came up with an idea of a set of colored lights, maybe a traffic light, and we executed a small project. It worked well because they knew the clinical problem. We had some students sitting in my sleep clinic to look at how I struggled with clinic patients, and they came up with a workflow, and that software was implemented on a trial basis. And our ongoing asthma and COPD projects also, there are students from the IISc who come and do data collection and sit with me on a regular basis to troubleshoot on how they should be doing their recordings and how they should be interpreting data, and that helps in effective translation of research. And ethics in research and publishing is something which youngsters should know about. Authorship, acknowledgement, and attributions. Always, when you work as a team, you have to give authorship to people who contributed to your research project. And that, of course, I think we are becoming more mature and we are including people who are involved in our projects. But in earlier days, it used to be professor is the first author and resident is the last author in our times. But it no longer happens. You have to acknowledge everyone, especially in clinical research. The patients who are subjects of your research have to be acknowledged. You have to attribute anybody who contributed to your research in any way. Plagiarism is a big thing these days with AI and ChatGPT and Copilot. You borrow others' words. So please be very careful about plagiarism. I know many of the plagiarism checkers will pick up even a normal sounding word as plagiarism, but be very conscious when you're quoting somebody or citing somebody. It is important to paraphrase. It is important to cross-reference and say, I borrowed this from somebody, rather than passing it off as your own. Publishing to check a box versus publishing for impact. I know early in our careers, many of us publish to finish or cross a milestone, but most of the time we should aim to publish for impact. It's not the number, but the quality that's important. And we should, last of all, have a balanced view of results of research. Negative results also drive science. Don't be shy of publishing or talking about negative results because it can define your next project. It can tell you what not to do, and always respect truth in science. Never manipulate results so that your research project looks good. Now, who are the facilitators of research? We talked about how to do research, what to do and what not to do while doing research. Mentors are one of the great facilitators in research. We know this from the Gurukul times. We know this from Greek literature. That's a picture of Telemachus and mentor and our famous Gurukul system. They are guides and role models with psychological support. And most of us need mentors throughout our lives, much like we need parents. And a good mentor is like a parent. A mentor not only leads you in the right direction, but also helps you in other ways by offering psychological support, criticism, and also networking and sponsorship. These are some of my mentors with whom I have kept in touch, shoulder to shoulder with a mentor in a research training program. It's a happy moment for me, a happy moment for my mentor. And this is a very successful moment when my mentor met my mentees, and this was a grand mentoring moment for all of us. So this is another thing which gives you immense happiness. And it's not only the mentors, the peer group is also very important. This is my current group with whom I work with in St. John's. The power of compounding with complementary skills. Please remember that research is not a one-man job. You cannot sit in a silo and do research. Silo is only for storing grains. It doesn't foster creativity. Exchange of ideas has to happen. One will be a good writer, another will be good in statistics, another will be good in data analysis, the other person will be good in proofreading. So the power of compounding with complementary skills. Hierarchy is required. So in this picture, you can see our senior professor with all of us. He proofreads all that we write. So hierarchy is required as in multi-generational families. You ask the senior person after you've done all the work, he okays it and then you publish. So the peer group is very important. Healthy brainstorming is important. And with a big group, you can facilitate multiple research domains. And last of all, mentees. Mentees are very important. They are foot soldiers. Menteeing somebody or teaching somebody gives you an oxytocin boost. To teach is always to learn twice. There are many things I have unlearned when I'm teaching my mentees, because there are things which I would have held on to, but when I actually speak them out, I'll realize it's wrong. I probably have been going down the wrong path. So speaking out to a mentee helps clarify a lot of things. We are foot soldiers of research projects. It's a wow moment when your mentee wins a prize or a medal or has an achievement. And these moments of glory are something which you cannot describe with words. This is my mentee hall of fame. These are the engineering domain, and most of them are medical. Whomever I could contact and whom I could get approval from, I put. This is not all-inclusive list, but I'm very proud of all my mentees. Many of them decided to follow in my own subject domain, in my footsteps, and it gives me immense happiness, much more than publishing, much more than curing patients and whatnot. So there are multiple sources of happiness. The most important anchors are support systems. To be able to do it all of us are not sitting in a research environment inside a cave. We have our families, we have our support systems, our parents, our spouses, our children. Support systems are very important. I put up this book because when I expressed my interest in the biomedical domain, my spouse gifted me with this book when I was doing my postdoctoral qualification, and he proceeded to teach me the contents of this book. We were about 2,000 miles apart at that time, but whenever he visited me, he would teach me what was there in this book, and I started reading about respiratory care equipment. 25 years later, he still accompanies me to conferences, brainstorms technical ideas with me, comes to my department and teaches people technical aspects of sleep, and he's here in the audience. Thanks to him. I have certain friends who have stuck on to me for 3+ decades, who are not work partners, but they are subject domain partners, accompany me to conferences, brainstorm with me, are part of my training projects. These are all anchors or support systems which help us progress. Final messages. Perseverance and open-mindedness are very important in research. Doing research is like growing a tree. The impact of research lasts beyond your lifetime. We should be open to criticism and flexible enough to change research direction. And if at first we don't succeed, we should be willing to try, and try again, like King Bruce's spider. This is a picture of a 400-old banyan tree in Bangalore. Those who are in Bangalore can go and visit it. It's called the Dodalad Mara. It's in another corner of Bangalore. So I will use this to drive home what I said about perseverance in research. I'm not a wine drinker, but I guess this is how drinking wine will be like. This was a research project we started in 2007, presented our first paper in an international conference in 2009. Everyone was happy about it. When you present your research in a conference, invariably everyone walks in and says it's very good. You get some constructive feedback, you continue research. We also continue to do that. Presented in another conference in 2014, another international conference. More people were happy about it. Did it again in 2019, 1,000 patients later, we decided to publish the result. This was in 2024. Came back with from the reviewers a copyright, and 17 years of work later, that some critical element in the sleepiness scale we developed probably had to be knocked off. This is like saying you raised a child for 17 years, one finger has to be cut off. So it was a difficult moment for us to knock off one question from the questionnaire, though it was a non-scoring one, will not affect results. It is an uncomfortable moment, but as a researcher, we have to respect truth in science. So the reviewer gave us the option of taking it to another journal who would perhaps accept it with whatever small flaw was there. But no, you have to respect what a trusted reviewer tells you about a flaw, despite the fact that we had been going on with this for the past 17 years. So we went ahead and published the same journal in 2024 with that incriminating item moved to the footnotes. And that is a satisfying moment because we respected the truth in science and went ahead with the publication. And lastly, how does one balance clinical and research lives? Choosing between benefiting a few as a clinician and impacting humanity and science as a researcher is definitely not a crossroads kind of decision. It's a long drive with planned and programmed breaks. So with this, I leave you with a quote from Professor Rinti Banerjee, who asks you this thought-provoking question. You can read it for yourself. I've asked this question to me 100 times after I read about her. And wishing all of you a happy Independence Day. Thank you.
Thank you, Professor Uma, for a very interesting talk. We have time for maybe a couple of questions. Anybody like to ask something?
Thank you. That was a really fascinating talk. I really enjoyed hearing about your journey. I have a different question on the sleep research, sleep medicine research that you've done. I found it very fascinating too. Just because you've looked at both urban population and rural population, one of your studies are looking at sleep disorders. So does it affect, maybe you've already done this, so I'll just ask the question. So does it affect neurocognitive dysfunction in the populations also differently, or is there an age component along with the rural or urban population?
So neurocognition and sleep itself is a difficult metric to measure because we don't have tangible scales. People have done fMRI and brain imaging and stuff like that. Mostly the cognitive domain and the executive functioning gets impaired is what imaging has borne out. But when it comes to actual tests of execution or cognitive tests, like I said before, it is not geography specific. If I pick up a test used in the West, like the MOCA or the Addenbrooke's, we have a publication on that, and start using it on the Indian population, it's a bit difficult. If I start them to ask them to start identifying a kangaroo or a walrus or some animal which is not available in India, or ask them to do a clock drawing test, we don't have indigenous scales, so that's an issue. So yes, but yes, the cognitive dysfunction is there. Regarding urban-rural divide, we don't even know the difference in prevalence. So we have not gone as far as cognition.
I am a lead colleague of Rinti Banerjee and my colleagues here. And very fantastic talk, very inspiring, as well as very deep insight into a most difficult subject when people have sleepless nights these days with all stress. So I think your work would be is very relevant in the given context of society in which we live. Having said that, I have three, not necessarily question. First is, have you used any simulation study in your course of work in order to substantiate your findings, which you may probably not be able to do on the patient group? That's one. Are you thinking of using AI in your future model of studies so that probably you have a more definitive answer the way society will evolve into the sleep disorders? Thank you.
So when you say simulation, you're talking of monitoring or?
I mean, when you use the engineering tools and the clinical side, probably sometimes you use electrical systems or mechanical system or other system to simulate your expected outcomes or your research path. Would it go this way? Those are the simulation studies I was talking about.
What we normally do in sleep is we monitor sleep using physiological signals, and we try to correlate clinically. But most of the times we are looking at one or two parameters. But to answer your question, yes, we are looking at other signatures which would help pick up hidden things. But we don't do simulation in that sense, except probably in the context of giving the patient a nap opportunity and trying to see if they're falling asleep by using monitoring. And regarding the use of AI, pervasive monitoring is available, but AI in sleep as such, I mean, it's a developing field. I come across articles and stuff on pervasive monitoring and the use of, the moment something is brought into the monitoring domain, sleep, which is a subconscious thing, becomes conscious and starts getting disrupted. I don't know if I got your question wrong, but we are not there yet. Yeah.
One last question.
Hi, it was very inspiring. Thank you for the talk. My question is, some of your work, you talked about publications and impact in that. And did you have any direction regarding you developed a sleepiness scale? So is it used everywhere in India, or how you can publicize that, or how any Indian doctors can adopt that? Any work take on that?
Yeah. So we attempted multicentric studies, but unfortunately there aren't too many sleep labs in India. So what we are trying to do is, by way of advocacy, we are trying to incorporate it as part of a sleep screening module. an education cum screening module. It's a copyrighted scale, so we are trying to see if we can incorporate it as a screening module among patients. When you approach clinicians to use it, clinicians don't really come back to you with data because not everyone is interested in research. And there is the issue of data privacy and then giving back data to you. So it is just gone. They are using it. They are happy with it. They are using your scale. So we have not reached that stage of maturity in clinical research for people to be able to report back to you. If I gave my scale, people would use it. But whether I get back data from them is a problem. So we are trying to incorporate it into screening modules.
Thank you, Professor Wang, for a very nice talk and sharing your journey and insights.